Let's say we had two functions, f and g. Let's say f was multiplied by 5 and add 2. And let's say g was multiplied by 3 and add 7. Now this isn't the usual way we define functions, but a function is just a rule that tells you what to do to its input to get the output. So if I gave a number to f, you would know what to do with it. You could easily compute that f of 4 is 22, because 4 times 5 plus 2 is 22. But a more typical way of defining f would be something like f of x equals 5x plus 2. So here we use the variable x to represent the input to f. But there's nothing special about my use of x. I could use any symbol I want to denote the input. I could have said, well, f of z is 5 times z plus 2. That's the exact same function. It's the function multiplied by 5 and add 2. I could even say f of potato equals 5 times potato plus 2, or f of house equals 5 times house plus 2. All of these represent the exact same function, and that function is the function multiply by 5 and add 2. But the important thing is, f is a function. It takes whatever its input is, multiplies it by 5, and adds 2. So if I asked you what is f of a banana plus an apple, that would just equal 5 times a banana plus an apple plus 2. We could do the same thing for g, but let me just define it in terms of x. I think you get the idea. So we'll say g of x is 3 times x plus 7. But again, there's nothing special with the symbol x. I hope it's clear that g of potato is 3 times potato plus 7. A composition of two functions means you take your input, whether it be x or a potato or the number 3, apply your function. So let's say we apply g. In this case, that means we take the input, multiply it by 3, and add 7. And then we take the output of g, the first function, and apply f to it. Apply the second function, and see what that output is. So this gives us a new rule to go from input to output. And that rule is apply g and then apply f. So let's say our input is x. If we put x into g, so write like this, what comes out? Well, what comes out is g of x, or 3 times x plus 7. Now let's say we want to apply f. What do we have to put into f? The input to f is going to be g of x, or 3x plus 7. What we're going to do is take the 3x plus 7 and then apply the f rule. We're going to multiply by 5 and then add 2. How we write this is f and then the quantity that we need to multiply by 5 and add 2 to. And that quantity is 3x plus 7. Now here's where people sometimes get confused, especially if we think of f as being defined by f of x equals 5x plus 2. And people see the symbol x over here and want to think it means the same thing as this x over here. But the x in the 3x plus 7 is very different than this x over here. The x in the definition of f is a symbol that stands for the input of f. But in the case down here, the input of f is this whole expression, 3x plus 7. That's why thinking f in terms of a potato or a house might be helpful. Because a potato is such a ridiculous thing to use in this math equation that it reminds us that it's just whatever this quantity is, whatever this input is to f, is what we multiply by 5 and add 2 to. In this case, the 3x plus 7 is the same thing as, let's say, the potato, or the house, or whatever it is, or z if you don't like using strange symbols. So if I want to write this out, what I want to do is take 3x plus 7 and multiply that whole quantity by 5 and then add 2. Now if you want, you can multiply it all out to get 15x plus 37. But the important part is right here. What we did is we took the output of g, multiplied by 5, and added 2. In other words, this is the same thing as taking g of x and then applying f, which we write as f of g of x. F of g of x is the function that takes the input x, multiplies by 3, then adds 7, takes that whole quantity, multiplies it by 5, and then adds 2. Right, this is what we have right here. Of course, we could simplify it to just multiplying by 15 and adding 37, but that's just algebra. The composition of f with g is this function, f of g of x. Or should I write it f of g of potato? Of course, it doesn't matter what variable we use for the input. If we want to write it without any reference to the variable, like we did at the beginning, we just said here's the function f, or here's the function g, without any reference to x or z or potato, then we could write it as f composed with g. That's the composition. The only trick is to remember that this means apply g first, then apply f. So we have to read it backward. We read it from right to left. First g, then f, when we say f composed with g.